based on carbon nanotubes and nanodiamond. Carbon nanomaterials have a wide variety of physical and chemical properties, dependent on the atomic structures, making them suitable of application in different areas of science. In particular, nanodiamonds are characterized by biological compatibility, low toxicity to cells, chemical inertness, large surface area compared to the volume, in addition, their small size, which follow them to have a potential use for application in medicine and biology, such as drug delivery and transport system. On the other hand, carbon nanotubes have potential application in electronic equipment, biological or chemical sensors, supercapacitors, among others. In the this work, multi-wall carbon nanotubes functionalizing with hydroxyl and carboxyl group have been synthesized and characterization sign this type of functionalization multi-wall carbon nanotubes have less toxicity and are more biocompatible than multi-wall carbon nanotubes in their pure state, which forward is used for biological application. Nanodiamond with multi-wall carbon nanotubes hydroxyl and carboxyl groups connected in the other to study and characterization the resultant hydroxyl. We working with nanodiamond where treated with luperox in uptakes, applied ultrasound for 1 hour to modify the surface of the nanodiamond in the order to promote between the both nanostructures. The synthesis composite were characterization using FTIR spectroscopy and scanning electron microscope and transmission electron microscope. We have experimental 3 steps. The first step is synthesis of nanodiamond by equipment Mars 5 is endothermal synthesis by microwave heating. In the next step is modification of nanodiamond by treating with aptes and luperox, applying ultrasound for 1 hour to modify the surface. In the next step is modification of nanodiamond with multiple carbon nanotubes with carboxyl and hydroxyl groups. We apply microwave heating for 10 seconds. In this diapositive, we can see result of nanodiamond obtained by thermal method by microwave irradiation. We have a size of 4, 5, and 10 nanometers. In the have image of transmission electron microscope of multi-wall carbon nanotubes with a hydroxyl group. In this diapositive, we can see multi-wall carbon nanotubes with hydroxyl group with nanodiamond aptes and luperox. In this diapositive, we can see multi-wall carbon nanotubes with carboxyl group with nanodiamonds with aptes. We have elemental analysis of multi-wall carbon nanotubes with nanodiamond aptes, and we have elemental analysis of nanodiamond with aptes. We have a little small nanodiamond 4, 5, 12 nanometers. In conclusion, we have demonstrated the nanodiamond with carbon nanocomposite with a bonding between the multi-wall carbon nanotubes and nanodiamond, and resultant nanodiamond particles are 412 nanometers in size and still retained a high percent of the sp3 structures. A transmission electron microscope analysis shows that nanometer size nanodiamond particles nucleate on the surface of the carbon nanotubes. The best results for homogeneous deposition of surface of multi-wall carbon nanotubes carboxyl groups were achieved with nanodiamond aptes. Thank you very much.